This is the Empower Podcast, released December 19th, 2021. Episode 570. Keyzermas All The Way.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics. And hark, what do I hear? Is it
Yes, sir.
the patter of little tiny hoofbeats and a jolly laugh? What is this?
Well, hey guys, happy holidays. This is Jeff Keyser from Mighty Ohm. I'm back.
Happy Keyzermas.
Woo!
Yes, sir.
Yes, sir.
Welcome back, Jeff. How you doing?
I'm doing great. So just for everyone listening, we have a tradition where we do Keyzermas sort of every year. And I guess Chris and I both, maybe we got a little busy or, whatever. But anyway, about 20 minutes ago, Chris said, hey, would you like to do Keyzermas this year? And I said, of course.
This is accurate, yes.
That's, yeah, and not making this up. And I said, of course, that sounds great. And when do you want to record? He's like, oh, in about an hour. And that was less than an hour ago. So
yeah.
Here we are.
Woo!
Hey, man.
Well, thanks for
Glad
having
you're
me.
available.
On short notice. I canceled all of my holiday plans just so that I could be here right now with you guys.
All of those 500-person holiday parties that everybody's having this year.
Yeah, right. Yeah.
You're like, I'm sorry, folks. I can't come. I can't dance with a lampshade on my head.
Yeah. Yeah. Well, thank you so much for having me. I can't believe that it's been a year, but here we are.
I can't even remember last year's show. Is it because there's that much of a...
I can't believe it's been only a year. It feels
it's been a year.
It has been a long year, but yes,
true.
I also cannot remember it. So
Yep.
I have the show notes from last year. That I have those up. That helps, I guess.
All right.
Did we talk about anything that's like really culturally insensitive or embarrassing given the events of the past year?
Yeah, you talked about all your kit sales, and I think this year, Jeff, talking about having parts to sell to people
I know.
one by one
It's
is
really
very
insensitive to everyone.
Yeah, you better.
True.
I would say don't talk about that. You'll hurt some feelings.
Yeah.
There was no component crisis in 2020, right? It's a 2021 phenomenon, isn't it?
I feel like in 2020, I ordered parts and the lead times were starting to get kind of long. And maybe this is actually like January of this year. So maybe you're right. It is a 2021 problem because I remember ordering parts to build kits. And for the first time, I couldn't get like LEDs, like really basic.
Right.
Basic
and,
stuff,
these are
jelly
through
bean.
hole like T1 and 3/4 LEDs. And it took about probably 3 or 4 months to get those parts. And at the time this happened, I was busy. It wasn't a big deal. But then when I went to reorder parts this year, that's when I noticed that things are really bad. So I think you're right that this is a 2021 problem. I think we were blissfully unaware.
Insensitive thing for you to say on the air that you could get any parts in 2021.
The factories were not making the parts, but there were still a lot left in the supply chain. And then I think it took 2021 for them to actually dry up.
Yep.
Right.
Once everyone panicked and hoarded.
2021, the year that the supply chain was bled dry and also our souls.
Yeah. The year the supply chain forgot is 2021.
Yeah.
It's like the corn syrup riots or whatever, which is in the Ready Player One movie. Like, he's like, it's, what is it, 2045 or something? It's after the corn syrup. No, the bandwidth riots and the corn syrup droughts and stuff like that. It's like add in the supply chain.
Yeah.
Yep.
Yep.
All right. What have you been up to, Jeff? Has anything changed? What were you doing in 2020 and what do you have been doing in 2021? Is it all still the same?
I'd say, yeah, more or less it is the same. So I contracted last year and I was doing kits last year and this year still doing kits, still contracting. So yeah, I think business as usual.
Didn't one of your products come out though? Like I thought one of the things you were working on was released.
Well, yeah. So this year I got to work on Valve's latest hardware product, the Steam Deck. And I got kind of pulled into that project at the beginning of the year while it still kind of felt like lockdown here. So it was great to have something that was super engaging, super interesting. And also to see firsthand how lockdown had kind of affected Valve, and, a company that I've worked with a long time, and a company that kind of historically I would have thought would have had a lot of challenges adapting to a work from home, 100% remote kind of a situation. But I joined as a contractor to work on the deck project early this year, and I was really blown away by how well they had adapted. A company that really kind of prized like in person, in the room style conversation. Like they have the whole Cabal system where people working on projects all sit together. I mean, it's like a COVID nightmare, right? Because historically, some of the game Cabals would have like so many people and so many desks that it's like hot in the room because there's too many computers, and like there's nowhere, you can't actually really easily walk because there's just people everywhere,
and there's just engineers shouting at each other and going, no, it's not gonna work.
Exactly. And that's kind of the environment that the Steam controller was born out of. So that's sort of, for me, the core of my experience at Valve was a lot of people packed in a room, really tight quarters, and literally, after CES we would all get sick, because everyone would be in the same room.
Though. That's just CES.
Yeah, that's like Conflu is what one of the guys I worked with would call it, Conflu. So anyway, that was sort of the image that I was expecting. And then working 100% remote, working at home, which I'd always wanted to work for Valve, but at home. And so I was able to finally like achieve this dream. And I have to tell you, and I guess this is kind of old news, but you only have me on the show once a year, so we kind of have to catch up. But to go from having all of my prior experience with Valve being sort of in the typical, I guess I'll say like corporate, it's like email is on Exchange, and not a lot of social of like chat programs and stuff like that, like a lot of phone calls,
you just walk over to someone's desk,
WebExes,
right?
and also doing that kind of stuff. Well, to experience the 100% remote version where we've got like 3 or 4 different chat programs. We're using like every, Zoom, Microsoft Teams, blah, 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 like the whole, like so many different online platforms for collaboration. For me, having not had that experience to sort of ramp up to that, because prior to that, most of the consulting and contracting I was doing was still just like email and the occasional Zoom call. And it was pretty simple. But to sort of go back into that kind of an environment where you have a company with a lot of people using a lot of different platforms and a lot of things that are kind of new post-pandemic, for me, it was kind of like getting on the freeway and the traffic is going 60 miles an hour and I'm like merging on, going 25. It was a very difficult adjustment, and getting single sign-on and everything to just work across all those platforms was sort of a project. And for me to learn how to use all of those online collaboration tools, I found it to be really challenging. And I felt like old. I joined and I'm like, oh my God, I'm like the dinosaur. I'm the guy who has like the old way of doing things sort of cached in my memory. And so, my first inclination, if I need to talk to somebody, is to like pick up the phone or shoot an email. And like email had sort of taken a few steps down, and a lot of people were not even using email day to day. And so here I am at the keyboard, like banging out these, long format emails about, hey, here's what I think we should do. And then you realize that no, actually, all of the activities happening
20 minutes ago.
Is happening on chat platforms, is happening on like Slack and things like that. And so I found that to be a difficult adjustment, not just because that's not what my experience at Valve had been before that, but also because this is sort of the things that everyone has sort of learned how to do. But because I wasn't working at this company during the whole progression, for me, it was a huge shock to go from not having that to everyone's using it, everyone's really good at it, and I suck at using these platforms. But I figured it out.
To quote one of my favorite Christmas movies, "Welcome to the party, pal."
Is that because it's the software people bring in their software mentality to the game?
Oh, like agile,
and
stand-up meeting type stuff, that kind of thing?
I don't think so. I think that it's really that these
is it
tools
because Steam is bananas and it's a free-for-all crazy place? Is that why?
I think that it's just that people were using any platform that was available in order to get the work done. It's like the work has to get done. You're working on a project that's got a really tight schedule, that's, got to ship on a tight timeline, and everybody's just got to figure out how to be effective in this new reality. And again, this is like probably super old news for everybody, but for me, this was a big part of my year, was like seeing and experiencing this. And I think especially in the context of Valve, and historically a company that you wouldn't think would be so good at this, of course they figured it out and they were great. And it was fantastic. And it even made it better when you go back in person, because if you're back in the office now, you have this rich library of collaboration tools. That means that the people who are at the factory or halfway around the world, they're a lot easier to communicate with. And I don't think that this is like a shocking revelation, but to see it firsthand, I thought it was super interesting.
What is the Steam Deck for people that don't know what it is?
If you heard both Chris and myself furiously typing away on our keyboards,
that's right.
Yeah.
What is this? Yes. What is this thing?
It's a handheld. It's like a patio, but it's like you go out there and then you catch a schwitz. Like that's that sort of thing.
It's a handheld gaming console.
Right. I thought so. So you actually play the games on it.
That's right. Yeah. Right. It hosts the content locally,
right.
And it's kind of like you take
a. It looks like a Sega. What was it? Not the Genesis. It was the Sega, the Game Boy, the Game Genie. It looks like a Game Genie. Ooh, that's what it is. Minus the 6 AA batteries.
Yeah.
Yeah. No more packets of AA batteries.
Yeah.
But
right. Just like burning through them like cartridges. Yeah.
It's a really cool handheld gaming system that runs Steam, runs lots of great games, and is super high performance, like has really nice GPU graphics processing, is like surprisingly great for something in that form factor.
It looks like custom silicon, but that's just maybe just the graphic on there. It looked like they had a chip that had Valve on it, but yes, no.
Ooh, I don't know. I can
big,
confirm nor deny because I don't
VGA
know. I mean,
fancy render.
Full disclosure, I worked on a tiny little piece of this thing.
Got it.
And so, I came in super late. There was a team that had been working on this for a long period of time, and I was very fortunate to join to help work on some specific things based on some experience that I had. Because if you look at the interface, it's like kind of familiar, right? Like, you can imagine how sort of the legacy of the Steam controller fits into this device. And actually, one of the funny moments of my time at Valve this year was that I got to work on a circuit that was called the Legacy Haptic circuit. And you definitely feel old when someone calls something the Legacy Haptic circuit, and you realize that is your haptic circuit that you designed, several years prior. So it's kind of cool to see that lineage actually of stuff that, the team that I worked with years ago on the Steam controller actually going into current products. That was really neat to see. Kind of makes you feel good as an engineer when, there's time has passed and somebody, if an idea works really well, it gets reused, and it gets used in current products. So I was lucky to work on a super tiny little piece of it. And it was a great thing, a great product, and something really interesting to work on in 2021 for me.
That is an interesting point about the coming back and seeing your work and whether it survived or not, because I've definitely I've seen some of my stuff did not make that transition.
I have an official dead projects list.
Wow.
Of dead projects I've worked on, sometimes for 6 months or a year or something or more, and they've been cancelled. So it's
I started my career in chip design. We've talked about that in the past, and one of the first companies that I worked for out of college, not the very first, because that was a startup that kind of went out of business very quickly after I joined, but the second company I worked for was a company called Serenza Microdevices, and I was a gallium arsenide IC designer, and I was only there for a couple years. But years and years after I left, like probably 3, 4, 5 years after I left, I talked to somebody who worked there, and they said, "Oh yeah, by the way, we're still making your stuff." In the chip industry, I mean, gas, I think, moves a little more slowly than silicon. But in the chip industry, to think that 3 or 4 years after I'd left the company that they were still making products that I designed, that felt really
it's
good.
either really good design or you're making stuff for military and they have to just keep making it the same way.
No, it wasn't military. But I mean, yeah, you also run the risk that they're still making it because like no one understands how to.
That's true too.
How to do anything with
it's
it.
the black box of.
But I don't think that's what happened in this case.
Yeah.
But
actually, so Dave and I were talking after recording last week. I don't think we talked, or 2 weeks ago rather. I don't think we talked about it on the show at all. But I mentioned to Dave that I'm working on like updating my portfolio site, and Dave mentioned this guy that he knows that has this amazing portfolio site where he tracked everything. What was it, Dave? Like the 20 years, 30 years?
20, at least 20 years, at least, probably more. Yeah. Yep.
Wow.
Of every project he's ever worked on at every company that he could, because I've worked with him at 2 different companies.
Yeah.
Technically 3. And there's many, like his biggest projects he's worked on, he can't put on there because they're secret, they're
that's right. Yeah.
actually, they're actually, but still the detail, and he sorts them by year. So we'll link that in. As Steve Howell is a mate of mine, ex Altium and ex Sercel and Tallies and everything else.
Yeah.
And he's just got an amazing site. It's old school HTML.
Well, it's very it's like handwritten. HTML.
It's handwritten. I don't think he's changed. It's the original code from like 1996 or something. But
cool. The thing about that is it loads really fast.
Yeah, and he documents every single project and then the process technology used. He'll say, "Yep, this was an 8-layer, X process on the PCB with this tolerance and this masking." All the little technical details are there for every project he's worked on. It's absolutely incredible. So
that's great.
Yeah.
Sounds like Jeff's would actually have a lot of active stuff on there still. So that's pretty impressive, buddy. More of that, I guess. Let's move on to the other pressing issue in terms of Keyzermas and Jeff being on the show. Where's my stuff, Jeff? You still got my HP 8753 in your house.
I do. I'm actually looking at it right now.
I know.
And the bill's in the mail. Bill's in the mail.
No.
He's storage.
He's like he wipes it down every day with a soft cloth. It's well taken care of, I'm sure.
I actually just put protective caps on all the B and C connectors on the back, so it is true that I'm taking fairly good care of it.
Way better than I did, I'm sure.
It's in a coveted spot in my office here. It's sort of on the list. I've been going through some old HP equipment recently. It's well known that these stupid RIFA capacitors that are in everything, which by the way, I think that it would be great if there was a list or a database of what equipment had these cursed capacitors in it.
Yeah.
Because it kind of seems like pretty much everything HP did in the 80s has them, like as a certainty. But one complicating factor is that I know that they're also in a lot of line filters. And of course, a lot of the line filters are potted. So it's not obvious like what's in there.
That's right.
And so I've been replacing line filters when I can, like if I can easily order a replacement. But then I have like a 3562 that has this giant, huge line filter that looks really custom and really unusual. And I'm not going to throw that away. Like I'll never get another one of those. So I've been going through and trying to replace caps and stuff because I have a lot of old HP gear here now. Yeah. And all of it needs some level of attention. And so the 8753.
I saw someone's RIFA cap thing, and I think it maybe was on your thread as you've been fixing yours, and someone like posted a photo of the RIFA caps, and I was like, oh look, they made Christmas toffee.
They're a meme now. Like they've totally turned into a meme. Like there's t-shirts you can get RIFA capacitor t-shirts,
oh, really?
and somebody's selling them.
I would love it. So. Oh, sorry to interrupt you, Chris.
No, there was someone said there was an acronym. RIFA stands for something like replace in.
Yeah, I said it's replace if found always.
Always.
Oh yeah, that's great. I love it. Yeah.
And but the thing that's I think surprising to me is that you can still buy these, and they still make this cap new, so you can still go on DigiKey. Yeah,
I didn't know. Well,
yeah. You can still buy them.
In the same sort of clear. Really?
And I've read that, they changed the formula, blah, blah, blah. But they look identical. I mean, they look literally identical. I would love to talk to somebody who represents that product line and say, like, WTF. Like,
So what is RIFA, first off? I mean, that's also interesting.
It's a brand.
It's a brand, yeah. It's like
a brand. I thought it was like a technology.
No, it's a brand name. No.
Okay.
No, it's they're just, as far as I know, they're just regular metallized polyester, aren't they?
They're
I
paper.
think.
They're paper.
Oh, they paper.
Yeah.
Oh my
That's
God.
the problem.
So I just
thought
typed
they were
rifa into
polyester.
Google, and do you
Really?
know that rifa in Spanish translates to raffle in English? That's pretty great. Put one of those in is pretty much like having a raffle inside your equipment.
You guys should get somebody from whoever owns that product line to talk about these caps and talk about why they're such a problem and why on earth they're still made. Like, I don't understand why you wouldn't just discontinue. Like, you can still go on DigiKey and buy those, PME 271Y capacitors that are like, reaching 100% failure rate as time goes on. Like, why? There's got to be a reason about why you can still buy these things new. Like, do they do something that's different or better or way cheaper, or like, what is the deal? Because I find it shocking. These things are basically little firecrackers that are in every piece of electronic instrument that
Jeff, tell us how you really feel.
Well, I mean, it's a huge pain in the ass to have to go replace these things, right?
Yeah.
Because sometimes they're buried like deep
from
inside.
Like the 80s and 90s and before as well, right? I mean, like, that's also, you have a lot of time fighting against you as well.
Of course, yeah. But I mean, my question is, if I buy a rifa capacitor today, in 20 or 30 years, is it going to reach the same fate? Is it going to meet the same fate? Like, I think so, but I don't know.
Yeah, but surely they aren't using the same technology anymore. They
look the same.
They look the same.
Yeah, sometimes the caps, though, they look the same, and then inside it's just two
surface mount,
two ceramic caps and a trench coat kind of thing,
Well, I mean, these parts have clear epoxy or whatever, some kind of plastic housing, so they can't hide too much in there. It's possible that they change some small thing about the packaging, but like, I want to hear about it. I want to hear somebody explain to me why the new ones are okay, and I want to understand. It's just weird to me that they wouldn't just discontinue this series of what has become like a cursed capacitor. Maybe it's just that the fact that, more than 5-10 years ago, nobody had ever heard about this problem. But again, it's just weird.
Kemet.
It's
Kemet.
they're Kemet now. Yeah.
But Kemet still has a PME 271 capacitor, which is like the infamous
I'm
series
looking
that
at the
has
data
failed.
sheet now, and it's
actually
they are
metal.
They are metallized paper film. So they are actually paper. They're metallized paper. Wow,
it's crazy. Come on, guys! Like, it's not the 1900s anymore. Why are we making capacitors out of paper?
Right. Glass jars with
electrolyte with oil in them.
The coil, the paper, the plates.
Well, anyway, so I've become curious about this just because these caps have become, very
infamous,
notorious, infamous, in the past few years. And sure enough,
positive press on the internet.
No, and I posted about this on Twitter, with the replace if found always, and Tom Anderson said, well, a lot of people who are restoring equipment, they want to replace like for like.
Yes,
and I get that, but again, I don't know. There's a limit to me. Like, I don't want to be going into equipment and replacing things. Like, the reality is that anytime you tear into a piece of equipment, at least if you're me, you always break some little tab or some screw is, it doesn't quite thread in right. And so, you put a lot of wear and tear on this gear by taking it apart, and stuff breaks. And of course you can't get parts
Jeff's
for
breaking
it.
my gear, Dave.
I haven't opened your 8753. Again, it's safe here. It needs to be. It needs to be serviced.
It's being held hostage. That's what I'm hearing.
Well, if you want to replace the caps, I'll send it back.
And for those who don't know, these are X-class capacitors. They're X-class mains capacitors. There's X and Y class. What the X-class means is that they're directly across the mains. So they're directly, that's why they explode when you turn them on. If they fail internally and there's a short or some low impedance thing, the energy just builds up in there and they just explode because they're directly across the mains.
The worst thing is that a lot of times they are on the main side of the power switch. Like, that's the real
exactly.
problem.
Yes, they're on the filter side. Yes, they're before the fuse sometimes. So so you've got the whole energy of your mains system behind that, so it can pump in as much energy as your main fuse back at your circuit board. So,
and I've heard that the part of the reason they fail is that people will disconnect equipment from the mains and then store it for years and years. And that's definitely true of the stuff I've got. I don't leave stuff plugged in. So it sits for years, and a moisture migrates into the package, gets into the paper.
That's what happens. Yep.
And then when you plug it in for the first time, boom,
Bam.
you get a lot of heating because you've got this lossy stuff that's in your dielectric that's not supposed to be there. Yep. And so, even the caps that I took out of this 35665 I was working on, and those are relatively new. It's not a super old piece of equipment. They had hairline cracks that you can see even without a microscope. You can see them with your eye. Had hairline cracks that are the indicator that they would have failed eventually.
Yes, because the cracks allow the moisture to get in. Normally they are hermetically sealed, but the plastic actually degrades over time, and all the moisture can, seep in through the plastic somehow eventually over decades, I guess. But if they're cracked, then yes, you're getting moisture in there, and moisture and paper, when you've got mains potential between them, they do not mix.
Yep.
So,
Yep. So Kemet, we want to hear from you. Why are you still making these things?
Yagio bought Kemet.
Oh, Yagio, we want to hear from you.
Company. Yep.
Why do you still make these? Why? I don't understand.
Because some people demand them. It's just like the video I released yesterday, which has been extremely popular. Why are flukes so expensive? Why do people still buy a fluke multimeter?
Because the market will bear it, guys. That's the
because they want to replace, once again, like with like.
Yeah.
Right. So that's why that's why they still make them. Obviously.
Bananas.
Is there any other company that makes? Please leave it in the comments if anyone knows any other company that still makes metallized paper X-class capacitors. Paper technology.
Tell us so that we can not buy them and buy something else.
Surely they would put not recommended for new designs, right? Stamp on, right?
Yeah.
The old,
Yeah. I think that's the thing is like you got to zoom out and look at the actual function that it's trying to solve or the problem it's trying to solve. And it's like there are other solutions there, but.
I think so. I mean, their X and Y class capacitors have some unique requirements. Like I think they're supposed to be self-healing, and they're supposed to be have properties which make them more suitable to be sitting on a mains connection where you have a safety related concern. But I don't think paper's the only answer because you can buy polyester film. I think you can buy other film caps that are.
I don't think anyone else makes paper ones. I thought they had gone the way of the dodo. That's why I was very surprised when you said that they were still paper. Surely they would have changed
I wonder,
it.
I wonder if they still use beeswax to seal them. Maybe they're just organic. These are organic artisanal capacitors.
Artisanal capacitors.
In the small town in the mountains of West Virginia.
Of Rifa, Switzerland or whatever.
Made with the clear,
filtered mountain water,
of Rifa Mountains.
Yeah.
Jeff, what are you fixing up? What is that the piece of gear you keep mentioning?
Oh, so it's a dynamic signal analyzer.
Yep, same as the one I've got. Yep.
Yours is a 660, I think.
Oh, is it?
Right? Yeah.
Hang on.
I know because I watched your video recently. And I think it's almost identical.
Yes, mine's a 660.
He's gone off to check.
All right. So mine's a 665, I think, which is very similar. It's a dynamic signal analyzer. So it's basically an FFT box. It's a box that, unlike a time domain analyzer like an oscilloscope, it's more of a frequency domain analyzer, kind of like a spectrum analyzer, except that DSAs typically are for really low frequencies, like audio frequencies. So they typically go down
different than a network analyzer as well, because that's more like time-based.
So a lot of DSAs will also do network analysis, but usually not like full 2-port. Like they'll do through, so you can do
they don't.
How some oscilloscopes have that. They'll use their source, and then you can plug a network in, and they'll give you a transfer function. So DSAs have been doing that for a long time, and they're sort of HP has a legacy, and actually HP is not the only player. What is it? Stanford Research
do them. I used to use an old Rockland one, which I'm sure they've gone the way of the dodo. Rockland. I've also used an Ono Soki, which I think is a Japanese one.
To be fair, guys, HP has also gone the way of the dodo.
Yeah. Anyway, there's a few old school manufacturers of dynamic signal analyzers, but there's hardly any left. And what ones are left are either HP or still Keysight will still sell you one. There'll be a PC based one,
right? Which actually makes a lot of sense because
of course
it's a
very
low
frequency
computer.
stuff. Yeah,
that's right.
And it's very computer intensive. Yeah,
right. And I think part of the reason that I've been interested in these boxes is that everyone knows that the FFT on most oscilloscopes sucks. Like oscilloscopes are generally horrible. The only exception I know of is the new tech MSO5 and MSO6. Those actually have a really good FFT. And so I actually started the year needing to do a lot of frequency domain stuff. And, I'm an RF guy. Frequency domain has been a part of my career, since I was in college. But the interesting thing is that if you're an RF engineer, usually your tools kind of crap out at 100 kilohertz. If you have an 8753, the 8753 I think might go down to 30 kilohertz or something like that. So
but generally that's about the limit. I think the lowest
that's right.
spectrum analyzer I've seen is 8 kilohertz or something.
That's right.
And it's
And so typically they have a DC block. They won't go to DC. And,
no, that's right.
The couplers that they use don't go down to DC. And so I became really interested in this because I realized that I had this hole where anything below 100 kilohertz, my scope sucked. So because I have a nice Keysight scope, but scopes generally are pretty bad for FFTs. And I needed to be able to look below 100 kilohertz because of a specific problem I was working on. And so I started to become interested in
maybe a haptic circuit somebody works on.
Well, I mean, actually,
we're not going to say that here.
Actually, haptics are a great example of a thing where you care about things below 100 kilohertz because haptics are generally pretty low in frequency. And so, part of the reason I started collecting this equipment is that I wanted to be able to do some work in haptics and understand haptic systems. And HP back in the 80s, when this equipment was new, the 35665 is actually 90s. So it's sort of the culmination. There's, I think, maybe the 35670 is the last one in the line.
And it was got one, but it's faulty, yeah.
Okay, so those were the ruggedized portable. The equipment that I have is not portable. Well, it's still...
Well, they do actually... HP did make a portable version of this DSA. I can't remember the exact number, but it literally it is a handheld. It's got an LCD display and everything else.
Ooh, yeah.
What is the portability necessary for though?
But its dynamic range is very poor. Well, portability is important because I've been out in the field where I'm doing shock and vibration measurements out in the field. And Okay.
So that is the area that I think is the most interesting application of these devices. So if you look at old DSAs, a lot of them have tachometer inputs in the back, or they have RPM inputs in the back. And one of the, there's some really fantastic app notes and white papers. I mean, HP authored hundreds of really, really, really good app notes. And there's a whole library of app notes for DSAs, particularly when the 3562, which is sort of the flagship. There was, I think, the 3561, which is the first one. These were all designed outside of Seattle, I think, as well as in California. So there's some kind of local interest too. The 3561 and the 3562, those were DSAs that came out, I think, in the early 80s. So they're pretty primitive. I think the 3561 has bubble memory and stuff like that. The 3562 does not. But these...
It's the 3560A is the portable handheld one. Yep.
3560A.
3560A. If you look up photos of that.
4 digits instead of 5.
Yep.
That's right?
Yep. Okay. And that is the portable LCD version. I think I used it once or twice back in the day, but its dynamic range isn't actually close to the desktop ones. Its performance is lower, but it's portable.
So it's interesting that it's clearly a much later unit, but they were kind of the model numbering is a homage to the 3561 and the 3562. Yep. So the 3561 was a single channel, and then the 3562 had an optional second channel. If you buy one on eBay, you have to be careful because all of them have 2 BNC or 3 BNCs on the front, but it was an option to get channel number 2.
Yes.
But if you do...
There's no circuit board behind the second
BNC
or something?
Literally, yeah.
But you want the second channel. You
second channel. If you want to be able to do frequency response measurements, you have to have 2 channels because it uses the first channel as the reference channel. So you sort of lose a channel.
Yeah.
So that's almost like VNA mode.
Yeah, well, I've just I did a video on this a couple of weeks ago, and I've linked that in, where you can, once you enable the second channel, you then get cross-spectrum analysis and, more importantly, coherence. And I've done a video on what is coherence and how to set up a test jig and actually measure the coherence.
Oh, this is when you were shaking the shit out of those
when I'm shaking the shit out of those TO220s. I did a follow-up video to that where I explained what coherence is, because when you don't learn this, and I titled it "There's something you don't learn in school," right? Because you don't learn about coherence. It's a mathematical concept, right? This coherence. I won't go into too many details. It's in the video if you're interested. But basically, it's something when you go out, once you start doing vibration testing and you see your results and they're just garbage. They're just garbage because what? I've got $1,000 calibrated accelerometer. I've got a $10,000 calibrated charge amplifier. I've got a $10,000 calibrated shaker. Why are my results crap? It's because you didn't set up your jig properly and you didn't measure your coherence.
PEBCAC. PEBCAC is the answer to that one.
Yeah, it's
well. So your coherence isn't that a measure of how related the output signal is to the stimulus signal? So
that is 100% correct, and it gives you a value between 0 and 1. So a mathematical coherence value of 1 means that all of your output signal was due to your input signal. So there's no other distortion in your test gear. There's no other external noise. There's no other vibrational resonance in your test jig. There's no, anything else. There's no clipping on your signal. There's no everything else. So, yeah.
So I think one of the things that's interesting about DSAs is that this idea of using them to do shake and vibe and mechanical modal analysis is what they call it. The ability to do this with mechanical systems, I think, is fascinating because I've always been kind of interested in the mechanical side, the electronic side. Here is a piece of equipment which has a tachometer input that's made to be connected to like rotating equipment to be able to look at whether bearings are failing because the vibration signature will change. Correct. And there's these great white papers and app notes from the 1970s and the 1980s about how to use this equipment to do this. And I've been kind of slowly piecing this stuff together because this is, again, stuff that they don't teach in school, right, Dave?
Yeah, exactly.
Like, this is just kind of a little bit of an oddball, but I'm sure that for people in this little bit of the in this niche in the industry, this is important stuff. And there's just so much out there about how to do this. Like, say you've got an enclosure and you want to know what are the resonances of that enclosure. Well, these days, if you were going to do this, you'd probably go to Audio Precision and you'd buy some really expensive AP gear, tens of thousands of dollars to be able to do this. Or you go on eBay and you try to find a 3562A, which essentially does the same thing, right? Or the 35665 is the nicer, later version that has a floppy disk.
But then you've got to know how to do it. You've got to have
yeah.
You can't just, as I said, you can't just plug in your all expensive calibrated sensors and shakers and expect to get a result out. It doesn't work.
Well,
like that.
I mean, the limiting
also
factor...
true of most test equipment. Just again, just one of the level set here.
Very true.
But this is much less tolerant, though.
Case in point, the VNA in Jeff's hands versus in mine.
Right.
Okay, sorry, not to derail.
No, it's very true. This is one frustration I have with a lot of new test equipment. There's a lot of nice multimeters and things that you can buy that have a lot of bells and whistles, but I feel like you kind of need a degree to be able to fully use them. I'll say a lot of digital multimeters that have touchscreens on the front made by, reputable vendors. I buy them thinking, hey, I'm going to have a great time with this piece of equipment. It's so powerful. It does so much. And then you turn it on. You're like, wait a minute. I have to learn how to program whatever its internal language is.
Having worked at Keithley, which I'm pretty sure Jeff's talking about, the thing is, like, it's a test equipment company. They didn't know UI at the beginning. They got better at it, but it's tough. I mean, it's just like a tough thing. Like it's a tiny screen. All of those are like tiny screens.
Yep.
Like even on the scopes, there are these huge 10-inch screens. And then now you're squeezing it down to a 5-inch, 3.5-inch screen. And it's just like, oh man, it's tough to get it all in there. Menu on menu on menu.
Yep.
It sucks.
That's true.
Another area where I've done this in is fluid dynamics as well. It's not just mechanical stuff. The fluid stuff happens down in the hertz region. Dynamic fluid flow over products, because I've developed underwater gear and all that sort of stuff is important. So you're using fluid dynamics and air dynamics as well for wind turbines and, so anything involving physical vibration, physical shock, fluids, air, all those sort of physical properties, this is where this is the domain of the hertz and the kilohertz, and even the right down to DC. I mean, these things will go down to microhertz, right? They actually, like, if you enter frequency, there's a microhertz button, right?
Yeah.
And there's a microhertz button for a reason, because that's what these things can bloody well analyze,
right?
You know.
And they're really their best for that. I mean, that's really their sweet spot, is very very low frequencies, because typically they top out at 100 kilohertz. Like 102.5 for some reason is like the max
and they'll halve if you turn on the second channel. It goes down to 50 kilohertz.
Yeah, that's right.
And,
so they're
the interesting thing about these is that with your oscilloscope, you might be used to having 10 times oversampling. So if it's 100 megahertz analog bandwidth, we've got a segue here. By the way, Chris, just setting it up. 100 megahertz analog bandwidth.
I can feel it.
Well, it's in the Reddit list, dude.
I knew where it was. You don't have to tell me where a segue lives, Dave. Come on, man. You're 11.
You're 11, yeah. So where was it? Yes. So the bandwidth, like the sample rate, it'll be 10 times that. So it'll be 1 gig sample per second. Whereas these things, you get 2.3 times. Just the minimum Nyquist.
And you can actually turn off.
It all comes out in the math too.
You can turn off the anti-aliasing filters too.
And have you seen the output waveform on these things? It's not like a pure sine wave. Often it's like a discrete step wave, because they don't bother filtering it, because they know that it all comes out in the math, right? When you actually do your sampling and calculations and you apply all your software and hardware filters, it all just magically vanishes. You don't need, you think this really expensive bit of kit is going to generate a nice pure sine wave test signal. No, go and look at it. It's just a step, a step approximation, but it's good enough.
Yeah.
So, just pops out. It's magic.
I think that, back to what you guys were saying before, you do sort of need to do your legwork to understand how these systems work, because they really expose you to the warts of FFT. Like, you kind of have to understand how window functions work, and what window functions are the right ones versus the wrong ones. And it turns out it matters. You can't just use whatever you can use Hanning or Hamming for like 90%, but sometimes you're going to get into trouble. And I think that's also, for me, I was not a great student in college when it came to DSP, and so I kind of wish I had maybe paid a little bit more attention, because now suddenly I find myself reading these papers about, and again, the app notes are fantastic. There's so many app notes on this stuff that you can read, and you kind of have to look at the ones for each piece of equipment too, because they sort of build on each other. So you have to go back to the beginning.
I can vividly remember my first day as a contractor working at the military side of things at GEC Marconi. First day on the job, I come in, and I was hired as a PCB consultant actually, but first day on the job, it was, can you go over and fix this vibration test rig with this charge amplifiers playing up? And my first words were, what's a charge amplifier? Like, I had no idea. Like, it's charge amplifiers.
What is a charge amplifier, Dave?
I had never worked with it. It amplifies
I'm actually
charges.
more curious about PCB consultant. I just imagine Dave walking over and being like, have you thought about using a PCB?
And it was like, I learned really quick what a charge amplifier, what a dynamic...
What's a charge amplifier?
A charge amplifier actually will amplify a charge signal down. Instead of voltage output from a sensor, you'll get a charge output from a vibrational sensor, like a piezoelectric element or something like that. You put it into a charge amplifier, and it takes out a lot of the noise, because you're only amplifying the charge rather than the actual voltage. It's not a high impedance voltage amplifier.
It's like a current meter, but it's a bit derivative. Did I get that right? There was a joke in there about integral too. I wasn't sure if I was going the right direction.
Anyway, there's a circuit. Go and look up charging. Anyway, charge amplifiers. Yes, there's a critical element, because basically the feedback of your charge amplifier will be an op amp, basically with a capacitor feedback element. So it's using a capacitor to integrate the...
Okay, there's a very high impedance input, I'm assuming, on these things. Sounds like op amp territory to me.
Yes, it's
especially because it's super low frequency. So op amps are perfect for this.
But back in the day, the problem we had is that you had to get NPO ceramics, right? These ultra stable NPO ceramics, and they didn't go past a nanofarad back then. But because you're dealing with low frequencies, you need, like the higher the capacitance, the better to convert your charge into right.
Well, they should have used Rifa capacitors. Come on. Metallized paper is where it's at. No, is it because you need to make sure the other dielectrics tend to store charge and stuff like that? Is that the problem? Is that
they're non-linear? Yes, they're non-linear. So you need the NPO not only stable with temperature, but they're linear with voltage as well. Like a lot of people don't realize your bypass capacitors, right? You stick in your 10 microfarad, or 100 microfarad bloody little 0603 ceramic in there.
They're garbage.
Right? It's got a horrible dielectric. They're garbage, right? Yeah, they're 100 microfarads in quote marks at 1 volt, but you take them up near their operational voltage and it just plummets, and they're so non-linear, they're just horrible.
It's so surprising to me that a lot of modern LCR meters don't accept bias. Like, it's weird that's not...
Yes, you need a benchtop one for that. You need one of the...
And you need to spend $30,000. I mean, or get
really?
a used one.
Yeah, several $1,000.
LCR meters are ridiculously expensive.
Hang on, I'm just going to have a check. I just bid on a LCR meter on eBay. A benchtop LCR meter.
Live updates.
Live updates. See if I won it.
If people were listening live, they could bid against Dave. They could,
No!
Yeah, what's the listing number?
It went for double than what I bid.
Ooh.
Oh,
whoa! It went for it went for 4 figures.
I can't take the heartbreak of eBay these days.
I think any Agilent or Keysight LCR that's fairly recent is a 4-figure meter.
Well, this one's a Wayne Kerr. I have to pronounce that correctly, Wayne Kerr.
Is this one of the ones that has a CRT display on it?
No, this is the modern one. This is the modern one with the color LCD and everything.
Oh,
fancy pantsy.
That sounds expensive.
Yeah. Oh yeah, they're like 5-10 grand brand new or something.
Wow.
Yeah, but I was hoping to get it for a song, but no, I was outbid. Yep. Yeah, it just finished 16 minutes ago, and it was more than double what I bid for it. So there you go.
Sorry. Boy. Dave. Sorry.
And I thought I was paying a pretty penny for it too. I thought I was. Yep. But no. There's always someone willing to pay more for their wanker gear. If you don't know, it's like, seriously, look up Wayne Kerr and the stuff they make, the high-end gear they make.
W-A-Y-N-E? Like Wayne?
Like in the name Wayne, and then Kerr, K-E-R-R. A lot of... I'm giving away some of my eBay search terms here. I've got a secret Excel list with all these obscure brand names that have all these, Anyway, Wayne Kerr's one of them. Okay, so I'm giving away one. And they make all this high-end, obscure, kit. And it's and they're still going, I think. I think Wayne Kerr's still around, and I don't know, they might have been gobbled up or something. I don't know. Does anyone know? Can we Google that?
I've never heard of it, so.
No. Yeah. Wayne Kerr. No, they make all this high-end gear, LCR meters and all sorts of other fancy test gear, like real high-end stuff. And you've never heard of them, right? It's like, why not? I don't know. But they make all these, $10, $20, $50,000 bits of kit. So, yeah. No.
Bespoke.
Wayne Kerr Electronics Test, they're still around. Yep. They do impedance analyzers, this is like the high end of the LCR type thing. They'll go the impedance analyzers up to 100 megahertz or something. So you measure your transformers, your inductance. They'll do magnetic analyzers, so you can actually characterize your switching transformers and stuff like that. You can get all the properties, nice. Like you hook them up, and they, if you have to ask the price, you can't afford it.
It does like the B&H curve.
It does the curves. It does everything else. It fully characterizes them up to tens of megahertz and stuff like that. And cool. They do all these right.
Really do you have any of those? That'd be a cool video to see.
Oh yeah, I know. I've been trying to get one for years, but they're so expensive. Like I'm not going to pay like $2,000 or $3,000, for a I should maybe, but no, I don't know. Because I'm actually trying to outfit my lab. I'm willing to spend a reasonable amount of coin to get things like vibrational test setups. I'm trying to get a new thermal chamber at the moment, but I can't. Well, I can. I found one that I really liked. It was really schmick from a French company.
That's heavy stuff, though. That means that's got to come into the country.
You've got to buy it locally, and you've got to spend a couple of $100 for the transport fee for the courier to actually deliver it. But yeah, I found this great one I like, and it's like used from this used test equipment dealer. This is not eBay, you know. There's specific like scientific and laboratory used dealers around. And I just got a quote. Oh yeah, $4,500 plus GST. Thank you very much. It's like, geez, for this used small, you know, little benchtop thing, you know, thermal chamber. I'm going, geez, well, what does it cost brand new? Holy crap, you know. And it's like I'm finding it incredibly difficult to get something like a thermal chamber like that has a decent range on it, you know, that I can do thermal experiments with. So I want to do thermal experiments. I want to do vibrational experiments, maybe acoustic experiments and stuff like this. And I want to set up specific test kits for this sort of stuff, but it's not cheap.
Sounds like a reliability lab.
Yeah, kind of thing. I just want to do all videos that no one else does. Jeff? You know,
he watched that Linus Tech Tip video.
I did watch that. This is where it came from. I watched that Linus Tech. If you haven't heard,
Linus, like, I got to go buy no more gear.
We talked about this 2 weeks ago. Yeah, we did. Yeah.
I have not seen this video.
This is just you dreaming about a new lab. You're like, anyway, more gear to buy.
Let's just cover it for Jeff. Linus is basically
drying the wash on top of a thermal chamber. You're going to be heating up your lunch in the thermal chamber.
Yeah, like he's basically come out and he's said that he's built, or is he renting? I don't know. This huge new building he's going to turn into a giant lab, and he's basically said if you're an expert engineer in you know, vibrational test, acoustics testing, if you're you know, in you know, thermal measurement and stuff like that, if you're a world expert in that, I want to hire you. And if you don't think I can afford you, try me, is what he actually said in the video. He's putting huge money behind this, and he wants like world leading experts to set up this test lab and run
Jeff, isn't it so sad during the holidays when some people get taken in by pyramid schemes and you know, just big plans, you know?
Right.
Anyway, I think it's fantastic. So you know, yep.
Jeffrey, how is Seattle these days? I mean, you're still up in the Pacific Northwest.
Yep.
How's the scene? How's the scene in the PMW? They don't say that.
It's good. I guess I feel like Seattle was already a pretty introverted place, and I think the pandemic has sort of amplified that. So, I say there have been a lot less gatherings. Certainly, we also sort of followed the letter of the whole guidelines, CDC guidelines, pretty closely. So there hasn't been a lot, you know, in the maker scene, but there was a holiday party a couple weeks ago, and we also had a hardware happy hour meetup last month that was great. That was at a brewery. You know, one of the challenges we have is that this time of year is so cold and wet that, you know, a lot of places, you know, they have outdoor, but like you wouldn't actually want to use it because it's pretty miserable. It also gets dark at like 3:30 in the afternoon here.
Well, no, screw that.
Like it is 3:12 right now, and the sun is like noticeably setting.
Oh boy.
So yeah, but I think things are great. I love living here. It's a great place to live. I feel very fortunate to live in a city that, you know, it's just got a lot of things of interest. You know, one thing speaking of kind of Pacific Northwest Seattle area, there's a fantastic museum in Bellingham, which is a couple hours north of here, called the Spark. The Spark Museum of Electrical Invention. Which is, I believe, one of the largest collections of antique electrical apparatus in the country. Like, it's the kind of place where you walk in with sort of, if you're me, you have pretty low expectations. You know, you kind of go in expecting that, it's probably like a, you know, kids museum. Nothing against kids museums, but you know, you don't expect there to be a lot of rich technical things for an engineer to sort of get into. Right. But yes, there is. And I don't know the full story behind this museum, but it was started by a couple guys who I think had a lifelong interest in collecting antique radios and antique, not just radios, but like antique electrical apparatus. So, you know, like one of the original Edison light bulbs is at this museum, and it's like one of a very, very small number of the original light bulbs. And that's just one example. Like they've got 100 other things that are kind of like that, like, you know, things that Benjamin Franklin worked on, and, you know, like when you have like the frog legs jumping and stuff like that, like they have that kind of gear. Like there's a lot of wood and brass and glass and voltaic piles and stuff like that. And, you know, I'm not super knowledgeable about that super early electrical stuff. So for me, it's super interesting to go and look at the stuff. They also have
reefer caps in there.
Yeah, we should have the Museum of Capacitors.
Of terrible ideas. Yeah.
They also have a Tesla coil show, which is, I guess, more for kids, and a bunch of other stuff. And I thought it was super cool. And I went in expecting I was going to spend like an hour there, but no, it's like big, and it takes a while to see everything. But Bellingham is kind of a neat, you know, smaller city in the Pacific Northwest, kind of a cool place to visit. And I want to go back and actually spend more time and look at more of the exhibits, because I thought the museum was really, really cool. And like I said, I think it's there's only a couple museums like it in the country. I think there's one on the East Coast that has a lot of similar, you know, antique voltage and current demonstration stuff. But yeah, it's kind of a treasure that's sort of hidden away.
Do you know what that's called? The East Coast?
I do not know. I don't know.
Oh, okay.
Someone from the East Coast will have to speak up.
I'm on the East Coast, so I'd love to hear about that. I will have many kids museums in my future, so that's probably I need something to offset it, you know.
Yeah. I also went to the museum. I have to look up what its name is. The Telephone Museum that's in Seattle, which changes its name on what seems like a fairly regular basis. It's in Georgetown, just south of Seattle. The Connections Museum, which is a museum with a lot of antique telephone stuff. So if you're interested in telephone things, the Connection Museum is another museum that I think is the most significant of its kind on the West Coast. And I think there is another museum like it, I think in Maine, which has a lot of antique telephone stuff.
Of course, yeah.
You know, we have to have our stuff. You know, the East Coast has their stuff. We have to have our stuff because we're on the West Coast.
I'm not flying to Seattle to go to these museums, probably. I mean, if
both of them, totally worth it. I think both of them totally worth coming here to go see. The Connections Museum,
18
especially
hours from Sydney to Seattle. Just
not a problem. Yep.
Yeah, not bad. I mean, once you're allowed out.
I would absolutely recommend, especially the Connections Museum is like really close to downtown Seattle. I think it should be like a mandatory visit for anybody interested in tech that comes here. It's not open 7 days a week is part of the problem. I think it may only be open on weekends, but totally, totally worth going. And a lot of the people that you run into at the museum are also people you run into at places like Tour Camp. So it kind of feels like they're part of the whole community of hackers.
Tour Camp is the conference that I sailed up to, Dave, if you don't remember that.
Yes.
That's the one up in the...
Yep. I remember
the Upper Islands. So yeah.
So yeah, sweet. Seattle is great. Great place to be, except for the getting dark at 3:00 thing. But that'll be over soon. The days are getting longer again.
Nice. We did have a segue, didn't we, Chris?
We did. You know,
I said that was segue.
Pull it out.
Yeah. What is bandwidth? What is bandwidth on the oscilloscope? And it's
this was James Lewis.
Someone who put it on here. You did.
I put it on there, yeah. But it's James, actually, who used to work at Kemet, I think. So,
he's got some answers, or I've got questions for him.
Right. Excellent. So, what is the video? He's talking about sample rate and bandwidth, and how people confuse. I watched a little bit of it. But,
that's right. Yeah, it's the usual, Nyquist, and you better go above Nyquist if you ever want to see something 10x. Nyquist is usually pretty good, that sort of thing. It's
Nyquist is 2 times, right?
Right. Nyquist is 2 times, but you want to go 10 times to get.
No, but as I said before, technically 2.3, or is it 2.4? I think mathematically, for a Gaussian response scope, I believe it's got to be a Gaussian response scope. You can get away with only 2.3 times above the bandwidth as sample rate. So if your bandwidth's 100 megahertz, you need 230, 230 meg samples per second. And then you're guaranteed not to alias.
I know for a fact that high-speed scopes from some of the big guys are not even 2 times Like
really?
You run into this when you're looking at high speed.
The old school ones are the old school multi-gigahertz sampling scopes. They had a 20 meg sample per second.
That's equivalent. That's equivalent time sampling though. So there's those, and yeah, like I think those have been around for a long time.
They have.
But even like the new single shot, like real time scopes, if you look at like a high speed 40 gigasample scope for doing like HDMI and DisplayPort testing, they are absolutely not oversampling more than 2 times for some of the really high speed stuff. And I've talked to their engineers about this, and they're like, oh yeah, this is, we don't need it for doing. And I think it's, the requirements of doing like mask testing are maybe not as rigorous as if you were using it as like a general purpose tool. And I think that they sort of like, gloss over a little bit of the wiggles in the signal and say it's good enough. But I was surprised by that.
Yes, because I do believe it's 2.3 times to reconstruct using sine X on X interpolation to be able to reconstruct the original sine wave. That's the mathematical guarantee. So it's actually slightly above Nyquist. So Nyquist has to do with aliasing, but this is talking about signal reconstruction. So most scopes will run sine X on X interpolation as a default. You can actually turn it off. I think there might be a couple that have alternate ways to reconstruct and like actually different to sine X on X waveform reconstruction. But yeah, if it's 2.3 times, you can guarantee that the sine wave you're seeing on the screen is legitimate with a Gaussian response scope. But if your scope isn't a Gaussian response over your bandwidth, like is as in the roll-off, then it's a different formula or something. So that's how it works. Don't ask me for more details. But they can get pretty close to that 2 times and still reconstruct the signal. So it's absolutely amazing. The mathematics behind it, magic, it just pops out. And it's just like I was saying about the dynamic signal analyzers before. You don't need you don't even need to generate a perfect sine wave into your test source for, because it just doesn't matter. Once you apply the filtering and the algorithms and everything else and the averaging or whatnot, it all just comes out in the wash. It all just doesn't matter.
Average it all out.
Right.
Nobody needs to see that. Yeah, that is interesting. I haven't seen the step sine waves, but I'll have to look more closely at that.
Okay. Anyway, I think Tektronix have an app note on this, like the 2.3 times. Tektronix. Anyway, if I can find it, I'll include it. They've got an app note that talks about it, I think. So I will find it.
Jeff, how is the world in consulting these days?
It's good. I mean, things have been good. It's been a good year, I guess. I feel like last year was tough. People were still trying to figure out like how to get things done in this environment, but this year has been much better. So yeah, it's I think as people like you said too, with like Valve learning how to work remote, it actually benefits hardware engineers who might be remote as well. I mean, everyone's remote by default basically, unless they're not. And that makes it actually kind of easier to hire consultants, I feel like. Maybe not structurally within a company, but at least from like a functional, logistical, everyday kind of thing, that's a little bit better. Yeah, I do feel like it's getting a lot easier to be remote. And yeah, as a consultant, I think that's an important thing. I mean, I'm lucky to live in an area where there's a lot of tech, but like if I didn't, I think it would be easier now than it has been in the past.
Yeah, my new spot, not a lot of electronics people here. So, yeah.
Hey, this one got the most upvotes on the Reddits. It's the evolution of the EarPod. I'm not into my fruity Apple gadgets, but this is a really cool...
This is just it's like a MRI scan, right?
It's like an MRI scan and the evolution of the AirPods. Yeah, it's just really cool. I just like how they've done these scans. This is just awesome.
Yeah.
Wow, it's very. As you scroll down the web page, the insides, it actually reveals all the stuff inside. It's really fascinating. So this is like a 3D scanning site, is it?
Yeah, this is kind of like those scans. I've shown you scans before using I remember M-Hub where I used to work. They had like a scanner like this, and then it seems like they actually took the layered data, like the layered PCBs that are in there, and then they started to. The magic of this particular website is they did a lot of post processing on it as well, which is like
exactly. It's very cool.
It's crazy.
Anyway, I'm thoroughly impressed by that. See, this
Just
is
like
the kind of tools I'd love to have in my lab. I'm actually trying to get a radiation license at the moment.
You're not going to get one of these in your lab, buddy. This is about $1 million.
I know, but a basic X-ray machine would be nice if I could ever get one. But you got to have a bloody license here to buy one.
This looks like 3D X-ray. I think these are CT scans.
Yeah, I'd say CT scan is right.
It's just so cool though.
Yeah.
Yep.
See, I don't get the show notes, so I have to use Google. Like, these guys are talking about AirPods. It's been on Reddit. But I did. It's the scanofthemonth.com.
We have a Reddit, Jeff. It's called reddit.com/r/theamhour. That's a nice reminder for the audience as well. When Dave and I are like, oh, it's on the Reddit. Yeah, that's people can add links throughout the week. And we'll talk about it. So if you want us to talk about it.
And you can upvote them, and the most upvoted thing.
You can subscribe to that subreddit so that it's on your Reddit when you're browsing while sitting on the toilet. You can read.
And every post that goes on the Reddit gets pushed out to the Amp Hour Twitter feed as well.
That's right. Yeah. So please don't post anything terrible.
Right.
I've actually got experience using a 3D X-ray like this.
Oh yeah.
Valve has one that's really, really nice, and there's a lot that goes into using one of these machines effectively, like how you fixture the part and stuff like that.
Yeah.
I took a class a couple years ago and got certified. I've got a little certificate that's posted somewhere in my lab.
But is there a scan of the certificate?
Pardon?
Is there a 3D X-ray of the certificate?
That's a flat thing, so I don't know. It wouldn't be that interesting.
Nothing is truly paper, flat. No.
True. We could roll it up.
Yeah.
But yeah, it's a great tool. It's one of those things that you don't. As soon as you get one, you start thinking of like things to stick in there.
Exactly.
And it helps with a lot of things. Like you can use it to do precise measurements of mechanical things. So normally you think about, you're gonna put a PCB in there and you get to see the solder joints and stuff, because those are like the high atomic number, like high Z materials. But it turns out that if you have like a single material, like a plastic, you can actually get a pretty good image. It's the dynamic range that's really tricky. So if you have like plastic that also has lead, like solder, that's tricky because now you have a high Z and a low Z material, and that really stresses the machine. But if you have just like a low Z material like plastic, and the entire field of view is this low Z material and then air, which is very low, you can actually get pretty good imaging. And one of the interesting things you can do with some of the more sophisticated machines is that you can bring in like a step file 3D model, and then you can compare that with your X-ray data and use it to do like tolerance analysis of like a plastic part, which is interesting by itself.
That's shot out of the mold. Like
and it turns out, it's kind of like looking at anything under a microscope. If you look at a plastic part under a microscope, which these 3D X-rays essentially are, they look really bad, because you see all the imperfections, especially when you've got the model sitting there. You see how flat things are not flat because, like you said, nothing is actually flat. You get to see voids, you get to see bubbles, you
Plastic
get to see flow.
Plastic is really hot, and it cools in funny ways.
So I actually got to work on something like that this year, where we were looking at measured versus modeled comparison of plastic parts, which is something I never would have really thought of X-ray as being the right tool for plastic because it's so hard to image. But it turns out that if you set up the problem correctly, you can actually use it to do some, get visualization in 3D. It's a lot better than using a micrometer or using, an optical comparator or something, because you actually get a 3D image of like it's called deviation analysis, where you can look at measured versus modeled, and you actually get like vectors that show you differences in the software. There's some really expensive, really sophisticated software for doing this stuff, like Volume Graphics is one example. And that's another thing that takes a while to sort of come up the learning curve. But as soon as you get it working, you kind of want to stick all sorts of stuff in the machine and image it, because, it's like anything. The more you do it, the better you get at actually setting up these comparisons. So these AirPod images kind of remind me.
I can't stop scrolling on this page. This is
it is really, really well done.
I mean, like just like looking at like the fold of like how they constructed the fold and like where the battery lives. Like I didn't realize that the stem was really, I would have guessed that the bulk of the AirPod, so if people don't know what an AirPod is, it's basically, it's a, thing, this little white nubs that you see in people's ears as they're walking around the Apple headphones. And the older ones, the original ones, had this long stem that came out, and that's where the battery cell is. It looks like a quadruple A or something smaller.
It does. Yeah.
And that's probably what informed that design, which is even crazier. Like, that's so cool.
Yeah.
So, yeah. Yeah, this is really great for like reverse engineering. I would like to see someone to recreate the functionality of an AirPod like this with like the multiple microphones and the the Bluetooth processing that's likely on here and all that stuff, and then stick it to someone's head.
But aren't there 20 million rip-offs of these? Aren't there like?
Oh, there are.
Everyone's doing them.
I don't know. I'm that totally exists. I want to see this with dev boards for each individual component that's in there, and then you like duct tape the whole mess to someone's head. Walk around like that. But then what you do is you're like, oh well, this is a Class A amplifier. I really just like the sound. It's like it's like a nice warm sound. Yeah, I need to carry a battery with a car battery with me, but it's worth it.
It'd be great if they posted the 3D files of these so that you could actually zoom around them in 3D. But yeah, it's great.
I'm not sure about the machine you use. The one machine, that machine I mentioned I've used in the past, the format was it was wonky. It like shipped out a .exe, and then basically each image you open this this standalone program basically, and then you could scroll in and it was self-contained in that way. It was very.
So you're saying it was a virus. Every image was a virus.
Yeah, pretty much.
Where the hell is the battery in the 2019 version? It's gone from the stem. Too. It's gone from it looks like it's circular. It's behind the thing, but geez, it's so much smaller volume. So they must have really got the power consumption down, because I'm sure they would have had like the same specs in terms of like life and stuff like that. Sure.
Oh yeah. Yeah, all these things where they get like 4 or 5 hours before charging back in the larger scale. Yeah,
it's crazy. And they've got to have inductive charging coils too, don't they? These are inductively charged, aren't they? They're not contact.
No, usually they're contact charged.
Are they contact charge? Oh.
I
thought you just threw them in.
Yeah, so if you guys are on the bottommost one, you can see right before it. Well, this is not going to work, but there's 2 gold contact points. But basically, because of how the case is aligned.
Yeah, I see it.
Oh yeah.
I don't think they have room for a coil. The coil would have to be. If you imagine like, Qi charging, you need a decently sized coil, or else you're going to have really low.
Somebody's probably thought about using the speaker as the charging coil, right?
Yes.
Ooh,
right.
Yeah. I want to be on that patent, Apple. If you see,
okay. Just saying. Yeah.
Yes, sir.
Oh boy.
So Jeff, what's in the year ahead for you then? More of the same, more kits, more Valve stuff, more consulting.
Well, the contract for Valve is up, so I don't think anything on that front. But
other people can hire Jeff Keyzer, the legendary engineer, to replace the Rifa caps.
Oh no, that's like a nightmare where you wake up and you're sweating, and the
Jeff,
Rifa caps are dancing.
No.
You
just
around.
Quote them a price. You just quote them a price.
Well, kits will definitely be a part of my 2021 if I can get parts. So, I mean, we started on that subject, but I have to say that I ordered the parts for probably all the kits I'll build next year. I've already ordered them, and it'll be, I think, May or June.
You can build them for 2023.
Well, I mean, you guys know how it is now. There's a lot of parts where if you go on Mauser or DigiKey, you do see 2023 as the dates now. So, I was actually talking to a friend of mine about startups and prototyping electronics, and it's like, I don't know how you would do it if you can't get parts next year. It's like, what are you going to do? Take the year off? Like,
exactly.
There was actually somebody on Twitter recently, and I wish I could remember who it was, but basically said, I can't get parts to build hardware, so I decided to go back to software again. And for me, I think that is like the banner tweet of 2021 is like, that's a sign that, hardware engineering is not in a great spot right now because of the supply chain stuff. If people are changing careers because they can't get parts because microcontrollers. I
talked to someone who was on their 8th rev of a board recently. The same board, just revved to try and use anything that's in this supply chain.
Oh, right.
8 single digits?
8.
That's geez.
Within like a
you
couple
haven't
months,
lived,
Dave.
Chris.
Come on.
You haven't lived. Come on. Single digit revs, come on.
I'm not saying for like functional over time sort of thing. I'm just saying that like, just for part shortages, I guess, yeah, maybe that's low. I don't know. Yeah.
It's not great. I don't know what's going to happen next year, but get your orders in now. I guess if you want to build anything next year, make sure you've got your parts on order. Bunny just had a post recently about that.
Just hoard like everyone else.
Well, yeah. I mean, that's the other consequence.
That'll solve the problem. Yeah.
Yeah.
What'd you say about Bunny's post?
Bunny just had a supply chain post just a couple days ago, and one of the lines in his blog post was about he had a component that was on a 28-week lead. So, you place the order and you say, all right, I'll wait the 28 weeks, which I think these days is that's the name of the game.
Standard.
And then he waits the 28 weeks. And on the 28th week, the supplier says, oh, by the way, we've decided to cancel your order. And again, that's another like 2021 moment.
Because somebody paid more. It's not because they're not making them. Yeah. It's because somebody paid. It's because someone like freaking Apple came along and said, we're going to,
They've already done that a bunch.
Oh, right. Well,
I kind of feel like we're getting to a place where unless you have the parts physically in your hands, you can't really trust that things are going to
do not send out a PCB until you have all the parts in your hand.
Yeah. Yep. We are. I mean, it's kind of. I posted a tweet earlier this year. Like, I would love to see the inside of DigiKey or Mauser's warehouses. Like, are they like subletting space? Is there like a go-kart track, or like, what are they doing with all that extra space? Laser tag, maybe.
Yeah, that's a good idea.
Like, what is, because literally the shelves have to be empty. Like, what is there? I mean, the warehouses have to be empty, right? Right? Like there have to be
I don't know. There's
miles
lots
of unfilled shelves.
Parts,
but like some staggering percentage of their catalog has got to be out of stock right now. Right?
Somebody, I guarantee you, somebody's going to, and this is a challenge. Somebody out there write a tool that scrapes the DigiKey or Mouser website and then processes it in like many different ways. I can search, or there's probably a market out. You could probably pay that as a service, like for what DigiKey don't tell you. Like, show me all the parts in stock for this kind of, like all the stuff DigiKey won't show you. I'm sure the data's there if you just scraped it all and then
Octopart probably knows.
I was going to say they're
what's going on.
They've got a lot of people scraping their site all the time.
Yeah, right. Yep.
Yeah.
That'd be cool. Yeah.
What I was thinking about this the other day, that it's getting to be where unless you are a tier 1 OEM, your access to parts, I'm sure you guys have talked about this, like it's getting, unless you're Apple, there's a lot of parts that you're not going to get this year. It kind of worries me as a hardware engineer, like kind of where does this go? Does it come back to normal, or does it get to be, unless you're working for a big OEM, you just can't be competitive because you can't buy the same stuff. That's kind of where we've been heading for a long time. But one of the things that, crossed my mind this week is like, what if we lost a major distributor in the United States? We've got a few key players in the electronics distributor. They're probably hurting because of the crisis in supply chain. Like, what if we lost one of them? How much harder would it get to develop electronics in this country?
I think they might be deemed of strategic importance.
You think so?
Like, seriously, I given that there is a focus now on, of course, bringing tech back to the US, bringing manufacturing back to the US, and supply chains, there's a lot of political pressure for this sort of stuff.
Yeah,
so you're saying that I don't think they're paying attention. Is too big to fail?
They're not paying attention to catalog, though. Like, I don't know. I think the thing that's going to kill, the things that would kill a distributor these days is probably just their, switching to a different business model. Like Arrow and Avnet are basically banks now. They're not like, they don't even hold stock, so like they've just opted out of doing that, entirely, basically. So not entirely, but, effectively.
I would bet that if, say, a Chinese company came in and tried to buy them, I think it would be blocked.
I think that's right, but I think that's a different.
Even though in the scheme of like companies, they're actually not that big a company. Like they're not like $100 billion company or something, right? So they're not that huge in the scheme of things, but they're so strategically. I think they'd be deemed strategic.
I think there would be focus on the. Yeah, I think that's probably got some truth ringing true there, but I don't think it's from a monetary perspective. I think it's more of a. Yeah, I think it's just there's sensitivity around electronics in general these days around that stuff. So yeah,
the trade wars are coming. No one else agrees.
I don't know.
You can't feel the vibe out there that, you know, the US-China tensions are getting worse, and no.
It's just there's me. What am I going to do about it, Dave? It's just we're just totally in reactive
I know,
mode here,
but you know. Anyway, hoard like there's no tomorrow. Because that'll solve the problem, people.
I've gotten to know new chipset families because of this. That's, you know, like you dig through, you're just like, what's going to work for me here? What can I get? Anything here, you know, I'll take.
Well, you can't get an STM32, so it's got to be something
anything
else. You know,
that's right. Yeah,
right.
So, you know, just keep an open mind in 2022. You know, maybe you'll use a new obscure part. Maybe you'll roll the dice on something you find in LCSC that like you've never heard of. You know, just there's a lot of electronics to be done.
Do Zilog still make their obscure? What is it? The what is it? The Z8? You know, the old.
Yeah, I put
Z80,
together
Z80.
No Z8. I'm talking about the microcontroller.
I put together a Blue ESR kit this year.
Yep.
And it uses I think a Z8 processor, and it's kind of a cool little chip. I presume that it was probably coded in assembly because that's a kind of an old kit. But yeah, somebody pointed that out when I posted photos online. Like, oh yeah, it uses a weird old Zilog, and you can actually still buy those parts. And I think they're in stock too. So let's go back to. We're gonna go back to PIC 16F, and we're gonna go back to Zilog.
Zilog Z8s. Yeah, and
maybe some like Cypress stuff, some old PSOCs. You know, some of the older 8051s.
Can anyone beat obscure one I've worked on? Rabbit 2000. Who remembers the Rabbit 2000 processor?
So we've heard about that before, but I
have used the Rabbit 2000. Nice. It had like 4 UARTs in it back when, you know, no microcontroller on the market had 4 UARTs. Like, you know, that was like, that was the hot ticket. And it had really nice real-time operating system integration with the C compiler. It was all integrated in there. It was all, you know, part of it. It was all you got your real time OS, and they had the like really easy calls in for a dummy software dummy like me who doesn't know about real time OSs and stuff like that. I was able to use it just fine. So yeah, Rabbit 2000. Can I name another one that I've used?
Have you done anything with the basic stamp recently?
Basic stamp. Well, what about the
Parallax propeller?
The Parallax propeller.
Yeah. Are they still making
They're still
those?
there. There's a propeller
I don't know.
Yeah, they're still out there. They're still out there.
Apparently that was done by one guy. That was one guy's thing.
Yeah.
He did the whole lot. I can't remember
Chip
his name.
and Ken Gracie. Those are the
That's
those
right.
Are the guys.
That's right.
Yep.
Good memory. Or quick on the keyboard there.
Quick
That's
on the
great.
keyboard. Propeller.
No, that was the old brain ticker, guys. That was the old brain ticker.
And that was a multi-core processor. That actually, I think, had 8. I think it had eight cores.
That's right. That's right.
Yeah. Hence the name, because the cores were a propeller. They were like cogs and outside of a wheel or something. That was the hardware analogy.
Yep. That's exactly right.
Yep.
And they had their own programming language called Spin.
Spin, yes, that's right. Yes.
The theme.
Oh, hilarious. Yep.
Well, now that we can buy those parts and not anything else, I guess we're going to see a lot of Parallax propeller designs in 2020.
Bring back the basic stamp. I can remember when that was, the basic stamp was the Arduino of the day.
Yes,
absolutely. It was huge.
Yeah.
It was the Arduino of the day because you didn't need a programmer. It had the bootloader in there, actually pre-programmed in, and you could hook it up to a serial port, right? And then you could just program it. You could dump your program in via the serial port, exactly like you do with the Arduino these days. In fact, I think the Arduino might have spawned, like the idea for the Arduino might have spawned from the basic stamp, like an improved version or something, or, you know, like a C version
similar.
of it. Yeah. In its concept, in having a bootloader built in. And it's you didn't have to buy a programmer. This was back in the days when an actual programmer for a PIC micro cost a fortune, right?
Yeah, they still do, by the way.
Right.
Have you bought a J-Link recently? Even ARM programmers, if you get the good ones, they're still going to set you back.
They're really good.
I remember amateur radio magazines. Like what was the magazine? Not amateur radio, but shoot, what was the embedded magazine? Oh, Circuit Seller, right?
Oh,
Wasn't
Circuit
that
Seller,
the
yeah.
embedded magazine. Like they used to have tons of basic stamp projects. Like
you
know, all it was like the bad old days, I guess. I mean, it was nice at the time, but compared to what we've got today, programming in BASIC seems pretty tough. Not great. I'm sure there's still people who are big supporters of what Pick Basic, and there's probably still folks developing with that stuff. But these days it seems pretty old fashioned.
Well, whatever gets the job done these days, that's what we're really getting at.
Whatever you can buy parts.
Yeah, true.
Well, I think our amp hour is well and truly up.
Yeah, I was gonna say, I think we should wish you a happy holidays and see you next year here.
Well, thank you so much for having me on the show, and maybe next year you can tell me. I'm gonna ask for at least 24 hours of notice.
Come on.
Where's the fun in
You're
that?
a consultant. It's fine. What do you got to do? It's a consultant. It's just it's just time and money. Just that kind of stuff.
Well, thanks for having me. It's great to talk to you guys, as usual.
No worries, mate. Awesome.
Happy holidays, Happy New Year, all that. And I guess I'll talk to you next year.
All right.
Bye.
Thanks, Jeff.
And are we going to have another show this year, Chris? Are we? Is that planned? Or is this it?
I don't know, Dave. I don't know. We'll see.
No idea. Anyway, catch you next time.